Welcome to the channel. Alright, so we got a few questions to ask today. We're going to get those up and running in a little bit. Alright, so we currently have to hook back up some clips real quick. So the outputs are both yellow, and I got the one that I needed to get. So this is easy. So I went from the 100 ohm resistor to the pot. Now I'm going to a 230 ohm resistor. We're going to see where that puts us. And then we'll start it up. We got a good response on the power supply from that. Alright, it does sound like the transistor is blowing here. Yep. Alright. So I got one option for that, and then we're going to go straight to our reed switch. Sorry about the noise though. The fan is going to stay on though. And I missed my screwdriver. It is obviously not my screwdriver. But it works as a substitute, I guess. let's do this again. Okay. So now we're not getting any reading. I know that's not right. Let's see what happens. No reading. Shouldn't take that much even. Alright, so we don't have a transistor tonight. What are we going to do about that? I don't know. Let's see here. Woo. Yeah, this. I also have a washer over here that's a magnet, and it's very powerful as well. Can you do a pulse motor without a transistor?
We are about to find out.
I'd say 100%
Dude, there's
viable yes to that question. Answer. Alright, so this has got to go down here like that. We're going to have to glue that down.
Troubleshooting's back and he said it's the spin-em-a-bob to electric boogaloo.
Right on, man.
Yeah.
Alright, so we're going to move the thingamabobber out of the way. I am printing a fan that is going to go on my other rotor. So that's going to be pretty awesome. And it is coming along just fine. Yes, indeed. And this is not plugged in, so I have to plug it in.
What's your best experiment yet?
I'm pretty sure it happened a long time ago. I think it was my Bedini loop, where I had 3 pulse motors that were basically running each other.
Oh, yeah.
It was pretty fun. Alright, let me see if this is gonna... levitate. Now the ceramic bearing that was in this one is in the other one now. But it'll still move pretty good. Here, let me adjust things. There we go. So it is maglev, but the bearings are kind of lackluster. Now, as for a coil, I was thinking maybe one of these 20 gaugers. It's 15 turns, 20 gauge. But of course, because it's maglev, it's at a certain height now that is above optimal height. So I gotta raise it up. So I got stands built, but you know, each one of these experiments is a different height. So you gotta build a different stand. Pretty much, for each one to be perfect, you gotta build a different stand. In other words, if it's not gonna be perfect, then you really don't need to bother, like, going all out, because if you're not gonna go all out, then don't worry about it. If you're gonna go all out, then you need to print yourself another stand. Seriously. Because it's like that.
Can you build a time machine next?
Yes. Yes.
I'm gonna show you what I got in regards to what I know about that. See, when you got the coils on the wheel, the pulse, the imprint pulse is different. It's way, way different than having the permanent magnet spin. When the electromagnets are the things that's spinning, I'm telling you, man, that imprint is different. And when I'm saying imprint, it's like when the magnet passes through space, it like tries to pull it. Even just air, it tries to pull it. Not noticeably, but I mean, it's there. And then when you put something that it does latch onto really good, you notice it like really good. But there's that effect all the time, except here. When you turn one of these off, that effect disappears after the collapse. So this is an on-off scenario that's spinning very fast. That's all I got for time machines.
Time machine.
So, like, anything other than, like, spinning electromagnets, I don't have anything other than that. Now, this one has got 120-degree holes. Okay, there's an opening every 120 degrees, and then every 40 degrees, there's a hole. But, like, in between each 120, there's two magnets, 40 degrees apart. So this is interesting. This is going to be fun to see what happens in regards to like speed and stuff. And we're just going to make a real simple circuit here. That needs to rise up just a little bit. So we need, let's see, one of these.
Do you work with schematics or graphic software?
I do not. I've been looking into doing a little bit more in-depth explanations Anybody got any suggestions? I do. It's been a while since I used it, but it's like, what is it? I forgot the name of it. Alright, so we're going to have to, I don't want to hold this. I'm going to have to glue it down. I got to glue that toroid to the table. So I'll put this over here, we're going to glue that. And then I need some clips, bada boom. So it's like, this stuff happens to me all the time because I'm poor. You know, I don't have stacks and stacks of stuff. I didn't inherit anything in this nature. So it's like, but it's like, I'm not complaining about that. That's actually an advantage in my life. Because it's forced me to look outside the box, kind of, more or less. I mean, the rotors are pretty simple. This one's pretty easy to center, so I'm going to just center it, because it is pretty awesome how like perfect the table is for that. Don't really need a disc or anything to center it, but oh no. I think the multimeter has got to be close to the most useful tool. The glue gun comes in a distant third. Tools, man. See, that's it, man. I'm pretty simple. The tool would be the multimeter, a drill, protractor's nice. You want a protractor. That's if you're going to build your own rotors. And you want a center hole. You want a center hole finder. You want a method of finding the center hole. If you don't use software, you want that tool. Tinkercad is definitely a tool. Software, I use that. Because the learning curve is pretty straightforward. You know, you want to put a hole in an object here, you put a hole in an object here. And I'm pretty sure it's like that. It's not really like that with other programs. I want to learn how to use other programs because you definitely can get a lot more stuff done. Like you can print threads. I don't know how to do that. So having a program that can thread is something that I would see as being needed eventually. Not just holes, but like if it's a thick piece of plastic, you're going to need to put threaded material in the hole.
Said I used to use
Okay.
What's your opinion?
Well, I'll have to check it out. I think it would probably be pretty cool. Sounds cool. Alright, and the glue gun's hot now, so that won't take forever anymore.
It is highly expensive. I used it in my school back in the day.
Oh, it is expensive? See, that magnet makes it spin like freely. But it's just two magnets opposing each other. It is on the rotor. I mean, it's not optimal, but it is very good. Alright. We're going to do this circuit real fast. Say it one more time.
He was on complimentary kid at school.
Okay, alright. Heck yeah, man. The school programs sometimes are the best. They got really good stuff going through some school districts, for sure. Alright, so we're going to do positive. It's going to go into the coil. Into the positive end of the coil, where it started, which is right here. And then from the coil, we're going to go to the switch. One end of the switch. And then from that end of the other end of the switch, actually, not that end, the other end, this end, it's going to go to the ground. It's the simplest circuit you can do. Alright. Turn that down to like 3. So I'm going to want to glue this down because it is sucking it like a vortex to the center of this thing. Actually, it's just the magnets pulling it. We are getting some lift here, some takeoff. There we go, man. It's spinning. Yeah. You really can't see it though. I'm gonna have to move it over. There it goes. I think it's working. I can see it arcing. Get the camera over here and see what's going on. Oh no. No.
Go to the park.
Oh, okay.
Alright.
Hmm. Yeah, my jack wasn't plugged in, man, so we're already down to like 10%.
Oh, man.
Oh man is right. But you kind of get the drift of what's going on over there, right? You got our switch, you got our coil, and you got 1, 2, 3, 3 clips. That's it. Pretty sweet. I'm gonna turn up the juices a little bit and see if we can pick up the pace.
Should see this says, yeah, Bale.
Woo!
You are making something M.P.H.
Alright, we got 6 volts in. We are drawing sporadic amperage. Anywhere from 400 to 800 milliamps. So this is a 120 void on a 90 or a 9 magnet rotor. I got a void at 120 or one of the 120s. See, there's 3 120s that are together to make a 9 magnet rotor that's even. An even 9 magnet rotor, I should say. And I removed one of those 120s. And I put it in a different rotor because I don't have any magnets. You know, I don't have any you know what I'm saying? So this is what we get. This is a 6 magnet rotor that's kind of shaped like a frisbee, one of those 3-legged frisbees. It's kind of what my fan looks like, a 3-legged frisbee. And then I'm printing. It's meant to scoop the air and kind of funnel it to the center. Wow, that is so awesome. That's actually really good. Starting to like kind of seize up, so moving it closer will cause that magnetic reaction to the screw to be a little bit stronger, and that might have to be enough to like unstick it, you know what I mean? So that's another thing that I got on my wish list is transistors. Uh, Looks like it's trying to go the other way now, doesn't it? Reed switches have always been really like finicky for me. Ah, there goes the bearing. Oh, good. Man. See, I took the original bearing out of there to put in the other vertical one. And it didn't, this one doesn't fit right. It fits well enough to do what we're doing. But I wouldn't put this on a fast one. Just had my life right now. It's not going to do it. But now the frequency, because I have it head on instead of to the side light, is increasing, which is awesome. So what's our question, bro?
Oh,
The poll.
would you consider joining as a member of the Master Club
Okay.
for a free 3D printed pro?
Okay. Yeah. All right.
We got 3 votes on it.
Right.
2 of them are no right now.
Gotcha. That's what we're currently offering is like a bonus for joining at the master level. So we're trying to see whether people like that or not.
We do have one.
Okay. Yeah. I don't think it's that bad. I mean, you have dimensions that you have to work with. I only have one 3D printer, and it's 8 by 8 by 8 pretty much. I think you get 9 inches up, maybe 10 inches up, but it's like 8 by 8. So this is simple. This is the simplest circuit that you can run. I mean, even down to the switch itself, it's basically just two magnetically induced connecting copper pieces. When a magnet passes, it'll connect. That's basically all this is. And it sends the pulse through the coil. It's a pulse motor. You know, literally that's what it is. That's what it's doing. Don't make it overcomplicated. And every time this thing clicks, this thing is collapsed and then opened up again and collapsed. Because it's 6 times the rotation. I wonder, you know, maybe we should hook the oscilloscope up to it anyway. See what's going on there. Hook it up. Where do we want to hook it up? To the coil or to the switch? Oh man, you gotta be joking. Alan McGokin. Leave this here, like, I guess we'll put it right here. Turn it on, turn it on. And we got our positive connection, which is our red node. You know, clip to the front of the beginning of the coil. And of course, put that to the other end. And I think we're going to be looking for this. Alright, so we have 3 going in from the power supply right now. So that looks about right to me. With all the loss that's happening and everything else. Oh, we can put this core in there. It's made for that. I mean, it's made for that one specifically. I don't know. Here. Actually, I want to see. We'll slide it in slowly. Oh, look at that. Nothing spectacular yet. Definitely gonna have to glue that down if we want to do that for real.
What results are you seeking from this experiment?
Results, I'm not looking at it from the rear end, but I definitely am trying to see, you know, what kind of voltage we're getting off of the coil from putting 3.6 volts of DC in with up to 200 milliamps. Seriously, it goes as low as 22 milliamps and as high as 300. I'm actually gonna back this out a little bit. So I don't know. Actually, I didn't like set it up to. Well, and that's the thing about experimentation. You want to know what you're looking for before you do it.
How many amps?
Currently, what do you want to know? Amps. About the amps. You want to know how many I'm putting in or how many I'm getting out?
Both.
Both. I see. We're going from 300 milliamps being drawn to as low as 22. That's what I said. And now, them being, I don't know how much we're making. I know it's not that much. I'd say probably around 60 to 100 milliamps is being generated here. There's no load on this, so it's not. Yeah, 23 milliamps. So I was wrong by a little bit. No, these things do not generate a lot of ampage. Even in raw electric form, they don't. But we are now putting 5 in. I want to find that sweet spot that I was at over here.
It says Python mode on here. Just use finger against speed. Oh, put mode on it, not Python. Put mode. Typo.
I don't know what that means. There's no electrical load that I'm going to put on this. I'm not putting electrical load on it. I mean, I could put my hat on it, and I could spin like that. You could do that. Let's do that. That's what you want, right? I'm going to put a load on this thing.
Yeah.
See, it's not even spinning. I mean, the load isn't going to help it right now. Sorry. I can't even, there's my hat.
Is this how the robots will extract our energy?
Yes. Yes.
I mean, if it's a hostile maneuver, it's very poorly orchestrated.
And that comes from Phoenix Fire Cluster Bomb.
Yeah. I'll look this up. Yes.
So what I'm going to do is I'm going to back this out. I'm going to shove this core in here all the way. And we're going to find out exactly how close we can get it. felt that. Holy cow.
He says that's interesting. It'll power the lie detectors. Yes.
Yeah.
Yeah, trolling. Those are fun. All right, let's switch the questions. You do. Are you building a pulse motor at home? We got 4 no's.
Okay. Instantaneously?
No, it's been about 10 minutes.
Okay. That looks like it's gonna go. Oh, that's... There we go. There we go. Yeah, so 900 or 900 volts. Just kidding, it's 9 volts. And in between 0 and 150 volts, or milliamps, not bad. That's awesome. It's actually reading 0 quite often. I don't see any stoppage here. Great, and that core, I'll tell you what, that's the difference.
So it's cool. Same guy.
Yeah. That's amazing. I mean, we are definitely spending more than we are generating, but it's really kind of right on par with what it's supposed to be on the high end of what it's supposed to be, which is a little bit less. I say if you put 12.5 in, and you get 12 out, you're doing really good. Yeah, man, this is good. I think this is great, actually. We might even turn it up a little bit. Let's see. Twelve. 12.3 volts. Let's take a look at the oscilloscope. Alright, so that's it right there, man. That's kind of weird. It looks weird, doesn't it? It's not what we're used to, is it?
Says it should be pulsing.
Oh, it's definitely pulsing. It's just not the normal pulse.
Okay.
Like a sine wave pulse, or look at, I mean, just look at the wave. It's totally sporadic. I mean, we are definitely getting a pulse, but it's like not. If we saw this as a heartbeat, we'd be like, this guy is sick. We need to get him to a hospital ASAP.
Yeah.
But it is cool. It is repetitive. It's a repetitive wave. So you can see that there's a break in where the 120s are, like the 120 void, I like to call it.
This is out of balance.
It's not out of balance. But it's a 9-magnet rotor that I removed 120. 3 magnets that were at 120 degrees from it. So now there's only 2 120 degree triangles instead of 3. We're not going to get much speed out of it though. That's unfortunate, but it's true. Occasionally it'll get up to like 300 RPMs. That's when it's going as fast as it can go. Now we got other coils here we can try.
You know how much the magnets weigh?
I'm thinking that all 9 of them together weighed about 1.5 pounds. So individually, I don't know. The math is 1.5 pounds divided by 9. Yeah, I can't do that right now. But I know that all 9 of them weigh about 1.5 pounds. And I know that 2 of them that are in here are slightly different sizes than the rest of them. They won't come out.
Are they balanced in the rotor? I think so by the way you printed the squares.
Yeah. Yeah, they're balanced. This one is designed to only run this way. So for what it is, it's made the way it's supposed to be. But this is 100% PLA infill, so it's a solid piece of plastic anyway. It weighed about 2 pounds when I was done with it. And then the magnets made it weigh about 3.5 pounds. Minus 3 magnets, so that would be, I want to say like a little over a pound for 6 magnets. That bearing keeps on wanting to come out. But I'm happy with how the switch is performing, actually. But I have a different rotor that we can try out. This one's going to function a little differently because it works with attraction on the maglev instead of repulsion like this one. And it's going to be a little slower, but it's going to be a lot more stable. Stability is key here.
It says good start. It says good job.
Awesome. Thank you. Appreciate it. Alright, so we're going to turn this off. I'm going to lift this up. You see, this is what I was talking about. If you didn't get what I was saying. The 2 magnets and then a void and then 2 more magnets and then a void. I think that would run really good on a transistor. I don't know why. I just do. All right.
You got it.
Nice. Alright, so this one, I'm going to put 2 of these little, really fast bearings on there. And we're going to put one of these slow lumbering ones on top of those. It just needs to go, the bearing needs to be wider than the hole, basically. Oh no, that's not right. Yeah, there wasn't enough glue on it. So it popped right up. So we'll run without it. Alright. I don't know what I'm gonna do, really. But this has got to stay on here. So I need to clear the glue off of this. If that broke anybody out, I apologize. Sincerely. We don't need to have the suction there, do we? The attraction? No, it's just another way the maglev is supposed to work when the glue is good. So we're just going to lay it on here like this. See, I want to glue it down once we get it in the right spot, but I don't. Like, I gotta move the glue gun over here. Not long enough to reach over here, so I gotta move it over here. Man, I'm not getting any arcage here. There we go. I don't know, I might need that maglev. Looks a little like stuck to me. At the very least, I need to reposition the switch.
William is back. He says hello.
Hello, hello. Welcome. Alright, we're getting a little bit of action here. It's nothing major. I think I'm going to put the maglev on. I'm going to put it on repulsion. So it won't be anything fancy like I was going to try. Man, it's hot. It's hot today. Turn it up. Take this off. Put it over here. I think we want to put this down here with this. Awesome. Awesome. Thank you all for your likes, appreciation, you stopping in. Now, since this one's going to be being pushed on, I don't see any like trouble with it like staying where it is. As long as it doesn't slip out from underneath there. Yeah, boy, look at how smooth that is now. That's amazing. The difference is amazing.
Another spin of a bar.
Indeed.
What is different from yesterday, yesterday and this morning? So I think it was that one.
Yeah. We are here at the horizontal pulse motor, and I am trying to get it to run. The difference is that one rotor was attached to the shaft and one rotor wasn't. And then there was some like, there we go.
Sort of looks like a spinning gym weight.
Yes. So this is also a 9-magnet rotor. It's a bit more of a flywheel. Well, they were both pretty much flywheels. They're both like over 3 pounds. Just like awesome. Here the magnets weigh like 2 pounds, 2.5 pounds. They're bigger magnets in this rotor. They're the 40 millimeter round ones. 40 millimeter by 20 millimeter. So we're going to try and get some speed up here to get this number to go up a little bit. But that's what's coming out the other end of the coil. So we're losing this in the coil. Literally, the power is going in the coil at 3 volts and about 100 milliamps max, and it's coming out the other end of the coil. This.
Yes, that's low torque.
This is a low torque, yeah. I'd say the ones with the shaft attached to the rotor have a lot higher torque. And I don't know why that is, and whether or not that has anything to do with how torque is calculated, but that's my opinion. And what I mean is, if you're trying to use the shaft to stop your pulse motor, it's going to spin on and on. It's going to rip your fingers apart. You know, lots of things are going to happen. It's not the best way to try and stop it. But it will show you, I guess, to some extent, how much torque there is. I mean, I get a feeling of how much torque is in the motor by grabbing the shaft when it's spinning. Yeah, that's how I do it. That's awesome. I'm like, yeah, that's how I do it. I just get my fingers.
By touch.
Yeah, touch. You don't want to touch it when it's going really fast, though.
Do you want to touch it?
All right, so this is 5. Yep, and it went up, but we're still like getting like less, and we're getting proportionately less. Because now we're at almost 5.5 in. But honestly, the amount of amps that we're spending is very little. Very little. I'd say the max is 200 and the minimum is like 20. Well, 0. The minimum is 0. But sometimes I guess, it's arcing every hit. So I don't know what's going on with this. But sometimes it says 0 on the meter here.
How fast will it go?
Not too much faster. Put a 9 volt in, this is 9 volts. We're still not even drawing like 200 steady, we're drawing below 200 milliamps. Below 100 most of the time. Alright, 12 volt battery. Pretty sweet. Not gonna go higher than 12 volts though. And look, we're only getting what, 5 AC volts. Let's look at our oscilloscope again and see what we're getting on now.
Alright, we got 20 volts. Have you ever made a pulse motor at home? 85% no.
Okay. It was a lot different this morning. So we're at 12 volts in, about 100 milliamp draw. Man, I might want to run my my battery thing with this, man. That'll be something. You think I can run a closed loop system with the switch that I got right here? With it not reaching much speed faster than this. You think I can run a closed loop system with my switch? See, I don't know, man. Oh, shoot. Oh, man. Alright, we gotta fix it. Alright. So the switch got sucked in magnetically. And that's why we want to glue it in here. Alright, I'm going to get the glue going. But it's in a perfect spot, I think. Where you get minimal arc, you get maximum maximum connection for how much magnetism is involved. So that's 3.06. 3 point. 5. Ooh, excuse me. Alright, I gotta get the glue in the gun. But you see why gluing this down isn't really a good idea either, because if you need to adjust it, you can't, because it's glued down. That's why I so much enjoy the fact that the glue gun's glue isn't permanent, really. It's not. You can yank it apart. Oh my, it's done.
Does it use or generate electricity?
Both. Both. See, now it's not even in a bad spot.
Can you use a sprocket system?
Yeah, I have no idea. I'm sure there's a gearbox out there that'll work with this. I'm sure there's a gearbox somewhere, somehow.
You get more power or more speed?
Right. But the amp draw is so low that I'm willing to give this a shot for my closed loop system. Literally, it's not above 100 milliamps, man. That's awesome. That is so cool. I don't think I've ever had one this low in cost. On my homemade switch, that is. Now, what did I do to reduce the arcage? Here, what did I do? I think I just added a coil for a resistor. I think it was this coil actually over here. It's 168 ohms of 32 gauge wrapped around the outside of this bobbin. It's pretty neat. The energy that's generated from this, it's just pretty cool. There's like a void in the middle. So what we want to do, we want to go from here to the front end of this coil. We want to take this one, stick it on there. Take the other one, put it to the switch, and that should reduce or eliminate the arcage without totally destroying the momentum. And then, you know, I don't know if that's
The bigger the battery, more speed, more power.
yeah, I know.
Question.
It's about resistance, really. But yeah, it scales up. All right, here we go. I do not see any arcing. I don't know if it's working though. That's the thing. So I'll try a different coil. there it is. Oh yeah. So we reduced the amp draw even more. And we got arcage, which is very low. Yeah, that's what we're gonna do. So there's an identical coil to this one, and it's worth 8 ohms of resistance. That's what I'm using right now. Perfect for this. I just moved it off the wheel to use it as a resistor instead of an electromagnet. I don't like the numbers there. That's pretty not good. I'm going to try hooking the oscilloscope up, or the multimeter, up to the next coil. What is that giving us? Oh, even less. That's probably because it's not on the wheel. It doesn't have a core in it. Man, oh, Beat definitely has a better switch than I do. He's got an awesome switch. His wheel would be going faster. That's what I'm saying. All right, let me get my my fan out of the printer. Alright, so it's hollow in the center basically, and I had to like use the support system, but all this is going to get removed. And that should slide right onto the pole. Back this up. It's kind of working, isn't it?
We gotta make this part fun.
Yeah, heck yeah. Alright, so look at how far back I pulled that coil.
Yeah.
Yeah! Look at how far away that thing is, man. It's literally like 5 inches away. 4.5. if it'll keep spinning though. I think he's doing a pretty good job so far.
Does the coil get hot?
Well, not right now, but it does. Yeah. It's got to be shorted out to get really, really hot. And it does short out, so yeah, it does get hot. I think this position for the switch is bad. It's a bad spot. There we go, just some repositioning. Hopefully that'll run for a little bit. Alright, so the reason why this particular circuit won't work in a closed loop system is because this particular system, unless it's hooked up a special way, doesn't generate your typical way. It's not a generator like you can't hook it up like the SSG. You just got your positive and your negative clip and you hook it up. It's not going to be like that because this circuit itself goes from positive of power supply to coil, from coil to switch, from switch to negative of power supply, and it's done. That, and you got to modify it. But I think it'll be worth doing.
Josh says my next project will use a Canadian coil.
Okay?
Canadian coin as the rotor, sorry.
Canadian.
Coin as the rotor.
What coin?
Which coin?
Which coin? But yeah, I encourage people to use other things than the 3D printer to do rotors. I mean, it's okay to do a 3D printed rotor, but I mean, it's better to use your imagination and stretch out a little bit. Like do what this guy's doing and turn a coin into a rotor. That's awesome. Hello, hello.
Is that the wheel of fortune?
Yes. And then I got the Price is Right wheel right over here.
Josh said he's gonna use the nickel coins. He discovered they are magnetic.
Okay. That's gonna be awesome. Yeah, man. I'll check that out for sure. I'm looking for my pliers at the moment. And I'm trying to get this support out of here. And run the pulse motor at the same time, which shouldn't be too difficult.
Alright, I got a question. How much would you be willing to pay for one-on-one instruction? We got 3 votes for $10 a month.
Okay. $3 minimum. Yeah, you can't just get what you need and you quit, man. That's what everybody does. I'm not saying it's wrong. I'm not saying it's wrong. I'm just saying everybody does it. I do it.
We all do it sometimes.
Default kid says, what is going on here?
We got the Wheel of Fortune running on a homemade switch. Yeah. And that's its max speed. This is the vehicle's max speed. It's like a, the chicken coop on wheels. Oh.
Welcome in, Ryan.
Alright, the cool thing is, it hasn't really slowed down much. We were going to do some awesome speedy stuff, but the transistors blew out and I don't have anything to replace them. So this is what we're doing tonight.
So what could that be used for?
What? Oh, this? This charges and revitalizes batteries. This can charge, can pretty much run itself. It's good for a lot of things. Am I doing any of those things right now? Not really. I'm just running this thing because I want to. I'm hooking this one. I'm doing this. I'm going to hook this. I'll show you what I'm hooking this up to in a second. Once I clear it up. Get a real job. This is not my job. I got knee-jerk reactions to some, more bonehead questions. And
Right.
what this is not a bonehead question. That's a good question. But there are some bonehead ways you can ask it. Absolutely.
We got 5 votes at $10 a month,
Nice.
and then $5 and $25 every other, and not once a month.
That's brilliant. You guys would pay $10 a month for my advice, and then you would stick around if it was good advice, or would you just jet once you found out what you wanted to know?
And I think we open a slot for a bunch of them to come in at the same time, and then we can do like a time grouping kind of thing.
Like painters do it. When they teach people how to paint, they do like workshops.
But we could even set up like a Zoom for that, or a Discord server.
Yeah, man, I could definitely, do the basics. This is the most basic pulse motor circuit you can have. This is it, right here. What better place to start than the frickin' beginning, you know what I'm saying?
Yes, the beginning.
It's like the people that start at the beginning get to the end and it's all done when they get there because everybody's already there. And it's not because they finished first, it's just because they started at the end.
Oh man, that's deep.
Yeah, it is. It's so deep, man. It's so deep. From a young G's perspection.
Do you look for the perfect place for the coil?
I look for the perfect place for the switch. I rarely move the coil. I like to keep the coil on the magnet.
What do you consider the coil?
The coil is the winding or the wrap of copper.
Oh, I think, yeah. Where it is now, do you consider that a perfect place?
That's a good question. I don't know. Because I moved the switch.
Like this, my eye, I read something different.
Okay.
All right.
Yeah, we're coming right along with this. And this is going to fit on the end of another one of my rotors. So the thing that's spinning is a rotor, for those of you who didn't know. Yes, I am being a smartass. Rotor is, I believe it's Greek and Latin for rotate. So, it means that it rotates or it spins. That's what it does.
Yeah, he just came in.
Hey Yanni,
Uh,
check that bad boy out.
Power supply.
pre-select. Joe, how do you use that power supply?
Literally, man, that wheel that's spinning right now is it's at 12 volts and it's literally drawing about 30 milliamps at its max and 0 at its minimum for legit 0.
How do you diagnose if it's broken?
What's broken? Circuit itself doesn't break really. It's either going to be the transistor. You can usually tell that by how many amps there's running through it and whether it's on or not. See if it's off and it's not moving and there's a bunch of amps running through it, you got a busted transistor. Okay? And if it's making a squeaky noise, once it's started and you stop it without turning the power off and it squeaks like really bad, your transistor doesn't work. It's not working properly. And I suggest that if you're doing something that blows one transistor, don't try and do it again. I do that all the time, and look at how many transistors are lying over here. Don't do it again. That's all I gotta say. If it's screwed up once, it's gonna screw up again. You really can't force this stuff. You can't force it. You gotta coax it. Just like making the rings of power, man. You gotta coax it. Okay? You gotta make it believe that that's its home, and then it'll go there. But anyway, this is supposed to go on here. So that'll be awesome. If we can get it on without breaking it. So we'll turn it to the side real quick so you get the side profile. I love this rotor. I would say let's turn it on, but the transistor's blown. So man, I'm bummed about it. I'm so bummed. And what happened was that I put the signal generator on the trigger coil, and then the clip fell. Basically, it just fell onto the wire next to it, and bam, that's all it took.
Well, blam.
Yes. And this is I guess it's supposed to be a counterclockwise spin, but I'm putting it on backwards, so it's going to be a clockwise spin. Yeah, I better slow down. Leave one of those undone, because I want to set that up right. Let me think here. How do I do that? So it's going to go like this, and it's going to spin this way. Right. So that's good already. Cool. Whether or not it does it both ways is not my concern. I don't care. I know it does it both ways, but we're only going to do it one way. Oh man. I know what to do. I do. I know what to do. I know what to do. Oh, please just tell me that I got the finesse to make this work. Perfect. So we're not going to put it all the way on. We're just going to leave it on the edge there. So whether that's a good fan design, I don't know. It was just there and it was available. It's not my design. I got it off of Tinkercad, their global library type thing. See, that's the benefit right there of having the shaft attached to the rotor. So we'll have a fan on one side, and then we'll do a flywheel on the other side to help create more motion. See, I just spun it with my hands, and it's going faster than the wheel behind it. Mm. And I'll turn this way, but it's clearly not going above 100. Not even going to 100 milliamps. So if I can set up a generator with this and have it do at least 12 volts with 20 milliamps, or an equivalent of that somehow, and be so, God, this is the cheapest I've ever had a wheel spin for. So cool, man. It was like giving me goosebumps just thinking about it, because it'll work. That, if it's like that, that'll work. But of course, nothing else is hooked up. I don't have a generator set up in the system yet, so. And in order to even fathom how I'm going to do this, I need to hook it up to a battery instead of a power supply, so that you can see exactly what I'm working with. See, because there's this middle wire, this middle connection to this cat bank that I've been dying to try out. I think with this system, I can try it out. It's a one-wire connection instead of a two-wire connection. And I think it's made exactly for this system, use for this.
What does it do?
Well, it takes AC in on one side and it goes out DC the other side. It gets rectified and it goes through a bunch of caps. So it's like a scrubber. It takes AC, turns it into DC that's perfect for a battery. But there's two ways to hook it up. You see, that's what I've been talking about. There's two ways to hook it up. You got your AC1 and AC2 hookup, and then you got this lightning bolt in the center. And I'm going to hook up the lightning bolt thing in the center. And then Here it says on the output it's minus voltage, positive voltage, and then in the middle it's O voltage, over voltage, or OV, whatever that means. And that's the center line coming out. So we're going to hook up the lightning bolt coming in, the OV coming out, and we're going to see what happens. But I have to rearrange some, whatchamacallits.
Alright, we got one for 25 and one.
Alright. There it is. Okay. Pum, pum, pum. Oh man. Come on, you gotta let me do this. Yeah, alright. Alright, that one's done. I don't know if I'm hooking this up right. It's just... yeah, we'll see. We will see. Wow, those ones have never been unscrewed before. Alright, so let's see if I was wrong about this. Okay. Put it right out there like that. Say what now?
One more like, get 20 likes.
All right. All right, let's see what happens. Nope, that's not right. Too bad. So the middle one is obviously for something else. Maybe it's a ground of some kind that I never used. Maybe. Alright, so now I definitely need an AC. I have to reconnect that. I'm not going to do that anymore. Need an AC input to get the DC output. Or you can put a DC input in and it'll come out DC. But basically it's DC output. And I'm going to use that to hopefully get a, I mean, look at that, spending is so low on the milliamps, it's unbelievable. Unbelievably low.
20 likes.
So I think this would be a good setup to run, you know, a loop. You know what I'm trying to say? Like have the battery and the charged battery be the same battery.
That low speed is awesome. It seems to almost start itself.
I did, kind of. But that's just because the switch was rested in a closed position. Alright, so... do I want to do this? Alright. We're going to do AC1. I think I've had like a minor stroke too, because I'm like remembering things less and less.
It's possible.
It's hot. I gotta get some. Hey Paige,
Yeah.
you get the waters out of the freezer before they freeze up too much? Thanks.
Johnny's showing some love.
Thanks, Yanni. What do you got?
He says, keep well, we love you.
Oh, thanks, man. I appreciate it. What's up, son? Yeah, I'll keep trucking, man. It's just a little heat stroke, that's all. Let's go here. What do I need to do? We're gonna clipping this. I'm clipping this right here. Oh, it works. Yes. Yes, it works.
Look at him go, he's super fast.
Super fast, like Sonic the Hedgehog.
Now race somebody's car.
You're gonna race a car?
Yeah.
That's how you get started doing that, huh?
I didn't race the car. Don't even have to use the weights.
We just hit 6,000 views.
Awesome. Awesome. Alright, so I got the cap bank hooked up to the circuit. So now this is the way the circuit goes. It goes power supply to the coil, from the coil to the cap bank, from the cap bank to the second coil, which acts as a resistor, to the switch, then from the switch to the dump in the power supply. So we added the cap bank, and right now I think it's working A-OK. Are they all frozen?
There's a fridge now.
Are they frozen now?
Maybe.
I wanted you to get in one.
Oh, I put them in the fridge.
What, are they hot or something? I'll be right back. Yeah, you're fine. Alright, see, look at that. Ice cold water. Brilliant. Whoever came up with ice, man, he's a genius. Actually, one of our ancestors invented one of the first ice boxes.
Yes.
So important. You don't even realize what you're missing until it's gone. You know? So let's see if we're getting DC readings now. Because it looks like We're definitely getting frequency readings. No, it's not coming in as DC. It's not. I guess the cap bank really cut how much energy gets through. I don't know if that's gonna be good. Our hertz are so slow. Look at that. That is snailing along. I mean, don't get me wrong, I'm not complaining. I mean, this might sound like I wanted to go faster, but I don't care. Not right now. We're in a wall. We're in like a waiting period where I need to get more transistors and a couple things need to happen. Then we can move forward. There is one coil that I do want to try. It's a 24 gauge coil. So this is 24 and it's like a whole roll of 24. Let's see what it does. Let's just move that over. This up and in here like this, up and in here. Like so. So this is 20 with the core, this is 24 without a core. And we're going to take the cap bank out for now. Don't know if there's going to be a benefit in this single line. Setup. In the series setup, I don't know if it's going to work. It's something to think about. I like that. I like how it's reacting. I like it a lot. 24 gauge for win, I think. Look, it's going like 24 RPMs. Oh. So I think this coil is gonna be awesome. It is a bifilar coil. It does have a 32 gauge strand. One of the ends broke off, but there's a little tiny bit of it there, so it's salvageable. So it's not totally broken yet. But it was the beginning of the coil that broke, not the end of the coil that broke. So no matter how much I unwound it, it wouldn't fix it at all. So I'm just glad there's a little bit of it left to work with. I'll clip it and then I'll just work with it like that. Right, pigs. Good thing. Where? Very little arcing. There's like no arcing whatsoever. Look at that. The current is all the way open. There it goes. It wasn't connecting. Yeah. Oh, that was my bottle.
$7,000 views.
Awesome. Wow. Thank you everybody for stopping in. Really appreciate that. See how this baby's picking up some speed now. Sometimes you just gotta make sure the contact happens. I think we're good right there. Yeah, steady amp drop about 40 milliamps. Hi, takes. Well, that just went down to 30. Nice. Good baby. So I gotta find a way to run a charging part of this whole operation, because the driving part of the motor is cheap, and I can use a cheap motor to run a closed loop system. But I think the way it's going to happen is either a bifilar or a trifilar coil, and you use the extra strand to charge the battery while you're using it to spin, I guess. We'll figure it out. We'll put the diodes where they need to go so that the system can function.
We're doing good.
All right. Now I need to get another water. Man, I am like dizzy. So good. And it's not really that I'm dehydrated, it's just that I'm so hot, my core is hot. So the cold water really is doing wonders. Because I'm not trying to hydrate, really. Just trying to cool off.
Only by like 2%. Because the arm, so basically when you do this is the more fast reaction. So when you're fighting, it makes like a fast reaction.
Yeah?
Because your arms feel lighter more than lifting.
That's true. That's what being strong feels like. Your whole body feels lighter. Things are easier to do when you're stronger.
Yeah, because when you get stronger, you can lift heavier things. It makes your body feel lighter.
That's true.
Because when you can hold like 100 kg something, your whole body just feels like a potato. Like when you're holding a potato, it just feels like that.
Thank you. So cool, man. Feels like a potato.
Yeah.
Yeah.
When you get to like 100 kV and you're still like light.
100 kilograms? I don't think so.
Basically when I'm 10, I will. Basically when I'm 10.
Wow.
And basically I was day to do this before I even race the car.
Oh, that's running so smooth. Oh. So how we doing, man? We ready to close up shop? 5
Yeah,
minutes?
7,500 views.
All right. Thank you all, ladies and gentlemen. I really appreciate it. I gotta call it for the night. I'm gonna go to bed, man. I think that's the best thing for me to do. So thank you very much. Really appreciate it. All you guys to hang out and everything. It's all good. It's gravy, man. It's awesome. So we'll get some transistors up in here. That's number one. We might get some copper to make a decent Bedini coil. That's 2. And I think that's all we got on the docket for right now, except maybe some potentiometers. And those are going to be the next in that order, probably, things we'll get. Thank you. Bye now.